and welcome. We are finishing off Chapter 6, text fields and loops. We've covered text fields, we've started loops, we covered the for loop in some detail. So we're going to move on today to the while loop and the repeat until loop in Lua. By way of just a tiny bit of review, there are three classic cases of repetition or looping. I've numbered them 1, 2, and 3. Sometimes I call them scenarios as well, but there's 3 scenarios or cases. The first is you need to repeat some action a certain known number of times. And for that, we've used the for loop. Because the for loop, you give it a number of times you want it to repeat. So if you know the number of times, then the for loop is the best choice. Scenario 2 is you need to repeat some chunk of code 0 or more times. You don't know how many times, but you can figure out when you're done using some Boolean logic. And then 3 is you need to repeat some chunk 1 or more times, which is really similar to number 2, except the difference is it's 1 or more instead of 0 or more. I have examples of each. So the 3 examples are you're in a team and you guys, well, you always remind everybody about an upcoming meeting. That's the for loop or case 1 example we talked about last time. Case 2 is if pizza is needed for the next meeting, you'll call or contact your teammates and get someone to volunteer. But pizza isn't needed every meeting. The way I've written it in the keynote is you guys only get pizza when you're meeting on a Friday. Maybe there's a coupon on Fridays or something, but so if it's a Friday and you're meeting, then you're going to have to try to get someone to bring pizza. So that makes it a 0 or more scenario, because if you meet, say, on a Wednesday, then you don't call anybody to bring the pizza. And then root beer is required. Scenario 3, root beer is required every time you meet. So you know you at least have to call one person. If that person volunteers, then you're done. If not, then the loop continues. So we're going to cover scenarios 2 and 3 today. And we're using this table of teammates, Harry, Ginny, Ronald, and Hermione. We covered the for loop last time, and just as a little bit of clarification in the keynote, if you watch the keynote closely, you'll see I actually used the surround with snippets approach to get the for loop to work. And that's what's illustrated in the keynote. But in the follow along, I used the convert to snippets approach. Because we've already had several examples of surround with snippets, I wanted to branch out and give you something, something new. But I don't want, sometimes there's a tendency for students to who are looking over this very quickly to maybe take the wrong lesson out of what I do and think, use surround with snippets every time we've done if-then logic, and so far every time we've done looping, he used convert to snippets, so maybe that implies that you have to use convert to snippets with repetition, and that's not true. That's not the case at all. You can pick. These are 2 approaches if you're coding using drawn to code to implement some sort of statement that surrounds other script objects. And the 2 approaches we've looked at are surround with snippets, which gives you a kind of a nice visual, easy to read stack, especially if you name your snippets appropriately. And then convert to snippets, which gives you one unified snippet to do your code editing in. So there's just 2 different approaches. You can use either one. All right. So while loops, again, you're the one in charge. You're making these phone calls. It's a 0 or more situation, because if it's not Friday, you won't do this. If it is Friday, you will do this. So the basic syntax of the while loop, the basic syntax is here, and it is the keyword while, a Boolean condition, the keyword do, and then the keyword end. While, condition, do, end. And everything between do and end is the body of the repetition, the body of the loop. It is what will be executed for a true condition. Okay. So as a first step, we're just going to do the same thing we did last time in our meeting, which is just create a loop that counts up to 10. That's the first loop that we coded last time. So I'm going to launch join the code. The first example for the while loop is just a count. So again, loops aren't in Drawing a code, so I'll need to do it as a snippet. So here's a new empty design and a new snippet, object 1. I like to start out with a comment that says what we're doing. So I'll say use while loop to count to 10. And then I like to set up the keywords so that they're there. So I need the while keyword, I need the do keyword, and I need the end keyword. I know I need that. Since we're counting, I also need a counter. So I'm going to say n equals 0. And then I need a Boolean condition. So I'm going to say n less than or equal to 10. Sorry, I'm going to start a 1, 2. That way I mistyped 10. I'm going to start at 1, n equals 1, and then I'm going to write the condition so that it's while n less than or equal to 10, do something. And inside, I know I want to print the number, so I'm going to print n. And it might look like that's all we need to do. It does sort of look like a complete, I mean, it is a complete statement. There's nothing syntactically wrong with this. The issue is that we're not incrementing n. If we ran this right now, with n starting at 1, the while condition would be true because n is less than or equal to 10. Therefore, this would be executed and it would print 1 to the console, and then it would repeat. And since n is still 1, it would print 1 at the console again, and then it would repeat. And then since n is still 1, it would print n at the console again, 1 at the console again. And in fact, you'd be stuck in an infinite loop. The loop would not end because we're not incrementing n, so therefore n will always be less than or equal to 10, because 1 is always less than or equal to 10. And you'll get at your console pretty much as fast as the computer can do it, printing of 1s out to the console. And it won't stop unless you kill it. I guess for the sake of education, let's do it. So I'm going to go into Mobile Designs, Chapter 6. I'm going to set up a new folder for the while loop. While loop. And this is count to 10. Here's the code. Save it and run it. Okay, so there it is. You can see it's just 1s. It's staying just 1s. Okay, so in the Corona simulator, well, it's not responding to the keyboard input, and I can't pull down the menu to do anything. It is just still stuck chugging along. So I'm gonna kill the Corona simulator then. So on the Mac, I right-clicked and choose Force Quit to do that. You could also pull up the task manager, the activity manager, and find that process and kill it. In either event, what you should see is just a string of 1s, and it's just a string of 1s because what we just talked about, we forgot to increment. We didn't forget, we purposely omitted a line of code that we need. So I want to increment n. So I'm going to say n equals n plus 1. Super easy. Let's save it and run it again. And now you'll notice that the simulator seems to be running fine. It's not locked up. It's reacting to mousing and stuff. So what you should see at the console is just the numbers 1 to 10. This is now working correctly. Each repetition, the condition is checked. If it's less than or equal to 10, the numbers printed out to the console, and the numbers then incremented. Then the condition is tested again. It does this repeatedly until the condition is false. So it hits the false condition when n increments here to 11. When it's 11, this Boolean condition is no longer true. It is false. When it's false, we jump out of the loop. And then if there was code here, it would begin executing your statements here. Or if there's not, it'll move on to the other code generated by subsequent script objects. Another thing people get confused about sometimes, if they're just skimming over the material kind of quickly, is they think that while loops have to have a counter. They do not. The while loop does not require a counter. The Boolean test can test anything that you want to look at. For instance, it could be testing an ongoing timer or another ongoing process. It could be keeping track of rows of data that are being read in until you reach an end of file or an end of line or something along those lines. It does not need a counter to do it. We use the counter here to count. I mean, the example is to count to 10. So that's what requires the counter, not the while loop. Occasionally I'll have students make their while loops and they don't need a counter at all, but they make a counter anyway. And then they get confused because they don't know what to do with a counter because it doesn't seem to do anything for them. And that's right, because you really didn't need, a counter. All right, so just keeping that in mind, I want to switch to this next design. This is the design where I've already set up the table. There's the teammates table. It is object 1, and I've named it setup teammates table so that it looks good and the stack is readable in the stack. And then I've added a second snippet, object 2. So in this case, I don't have any script objects that I need to surround. So I don't have to pick, do I need to convert to snippet or do I need to surround with snippets? Because there's nothing I would surround. I'm not going to surround object 1 that sets up the table because that would repeat setting up the table. I don't need to do that. I set the table up once, and now my task is to write it so that instead of just counting to 10, we move through the teammates table and do something. And again, I'm using a little bit of make-believe here, and then I'm pretending that there's a function called place call, which will do the call. There is not. We're not going to do place call. We're going to do print. Something along these lines to make it look like that we're calling each of our teammates. So I do need a counter for this while loop because I want that index number, that integer index number, to use to pull data out of the table. So I'm going to want to set up an index of some sort. I need the while loop, so let me just be consistent. Let me add a comment here that explains what we're doing. So we're going to loop through teammates to call each one. So again, I'm trying to write an example of a while loop that is faithful to the scenario of calling each of your teammates to get them to volunteer to do something. So the while loop has the keyword while, the keyword do, and the keyword end. So as to not forget it, let's go ahead and increment the counter. So I'm going to say n equals n plus 1. I know I need to do that. I need two things. I need a Boolean test, a condition. So I want to test not against a specific number, but I want to test instead to see whether I've reached the end of the table. So I'm going to say while n is less than pound teammates. So this little bit of syntax here gives me the number of values in the teammates table. The syntax works for simple tables like we're using here, and this also then enables us to add or remove members of the teammates table and not break our loop. If I hard-coded in 4 here, and then we drop somebody from the group, then we'd end up with an index out of bounds error in Lua that we don't want. Okay, so what am I doing? I'm going to print, just to make it slightly more realistic than even I have in the keynote, I'm going to say, hi, teammates n, and I'm using string concatenation here, and so we're calling them to see if they'll bring pizza. So I'm going to say, hi teammates, and comma, would you, I'm going to wrap here, would you please bring the pizza, question mark. end quote, in parentheses. Trying to wrap just enough so that you can see everything on screen, but not so that it fragments up the string so much that it's confusing. Okay, so if this works, it should produce this bit of string out to the console, which greets each of your teammates and says, would you please bring the pizza? So let's save this. I'm in Mobile Designs, Chapter 6, the while loop. And I'm going to say this is ask for pizza 1. Save it. And run it. All right, so it says, hi Harry, hi Hermione, hi Ron. So I did something, it's less than or equals to. So you'll notice it only ran through the first 3 names because I forgot the equal sign. That should give us our 4 greetings. Hi Harry, would you please bring the pizza? Hi Hermione, would you please bring the pizza? And so on and so on. Let me see. So there's, to be faithful to our scenario, there's 2 things we're missing. One is, at least 2 things we're missing. It has to be Friday, so we need to test to see if it's Friday. If it's not Friday, there's no reason to call anybody because we don't need pizza. And then unlike the for loop where the job was just to call everybody, in this case, your goal is maybe not to call everybody. Your goal is not to call everybody. Your goal is to get someone to volunteer for pizza. So once somebody volunteers, you're done. You don't keep calling people and asking them to bring pizza because Ron or whoever volunteered. As soon as somebody volunteers, you're done. You don't need to continue the loop. So how do we build that into our code to make this a little bit more realistic? So Friday, your computer knows what time it is. I mean, somewhere on your screen there's a clock, I assume. It's currently, for me, 10:31 a.m. Your computer knows what day it is. Your clock might even say, mine says Monday. Your computer knows all of this. And programming languages can access that data for programmatic use in your scripts. So the syntax is very similar to other languages. In Lua, there's a table called OS, and there are functions inside of it to do stuff with the operating system. There is a function called date, and date, as you might expect, returns the date. You pass it a parameter in quotes. I linked to a website with documentation on this, but for our purposes, we don't need the time, we don't need the month, we need the day of week. So to get the day of the week, we pass it %A. As an example, this is the little expression that will do this is a little Boolean expression that will test to see if it's Friday. Jumping back to our example here, I want to add logic to this condition that adds the realism to it. So in addition to the counter counting through the table and stopping when I'm through the table, I want another test to also be here and to be true. So I'm going to say and os.date %A, close quote, close parenthesis, double equals, in quotes, Friday. Okay, so I've added this second logical expression that looks to see whether it's Friday or not. So if we save it, what you see is, well, nothing. Where'd the names go? So I'm not seeing any names. Do you guys know why we're not seeing any names? It's not Friday. So let's change it just so that we know that it works, right? Let's change it to Monday. Sorry. Let's change it to Monday. Or if you're not in Waco. I guess it's possible it could be Tuesday already for you. So pick the pick whatever day of the week it is in terms of testing this, and save it and run it. And here are now my greetings. This is going to be a long set of Boolean tests here. You can see I'm already taking up almost the width of the screen. If I make it any wider, it'll cover my face, which obviously we don't want. So we can break it up. You can do the same thing we do with strings and break up the logic. So there's a first expression, there's the second expression, anded, and we're going to add one more. So what is that one more? Let me jump back to the keynote. So we took care of Friday. Now it's, do I have a volunteer? We want some way to faithfully replicate this idea that somebody might volunteer. You know, maybe to make this loop a little bit more faithful, you would do something like every time you make a call, you just flip a coin. If it's heads, then that person has volunteered. If not, that they haven't. There's no coin flipping necessarily in programming languages, but you can simulate it by using math.random. So math.random generates a pseudo-random number between 0.0 and 1.0. And then you could write an expression something like this, which is math.random greater than 0.5. So about half the time, the number should be above 0.5, and about half of the time it should be below. So this gives you something very close to coin flipping odds. The heads will be, let's say, greater than 0.5, and the heads will be, hey, you volunteered. So I need to add this bit of logic here into our app. So I'm going to say volunteer equals false. So I'm starting out by saying I don't have a volunteer. I don't have a volunteer because I haven't made any calls. So that makes sense that this would be false. And I want to add another Boolean test here, and that is and not volunteer. So that is simply saying while I don't have a volunteer. And then I'm going to flip the coin. So in the loop, again, trying to be faithful, I'm going to pretend that we're doing this call. So we've said, hi, Harry, would you please bring the pizza? And now we're going to see. We're going to flip the coin. So I'm going to say volunteer equals math.random greater than 0.5. So this is a Boolean condition as well, which means its result is either true or false. So the result of volunteer equals math.random greater than 0.5 is either a Boolean true or false. If it's a true, then that person did volunteer. So how about let's even be a little bit nicer and say if volunteer, then print thank you. Let's save it and let's see. So what we've got is we called Harry and he didn't volunteer. I know he didn't volunteer because we placed another call. Second call went to Hermione. She said she'd do it. So way to go Hermione, right? We're still not perfectly faithful to the scenario. It is possible that all four of our teammates will say no. The coin toss will be 4 tails in a row, for example, in which case we would need to start over. And that's not terribly hard to do, but I give you an opportunity to see if you can figure it out, at least to think about how you would figure this out. So as it's written, it will not jump to the next teammate. So I need some way to reset that counter back to 1. Okay, the repeat until. Situation 3, you need to call until someone volunteers to bring the root beer. Since you always have root beer, you know you're going to call once. If that person agrees, then you're done. So this is actually a good scenario for repeat until, because we know we need to place one call no matter what. We could code this with a while loop, but it's more fit to the repeat until loop. So using repeat until loop will make our coding a little bit simpler than if we coded it with a while loop. Okay, so the syntax for repeat until is the keyword repeat, the keyword until, and then a Boolean condition. In between repeat and until is the body of the loop, that is where the code goes that we want to repeat. And you can see I've actually written it out in detail here as step one, just so that, well, for whatever reason, I've just jumped right to the solution here. If you look closely, it's also got the solution to the activity I just gave you. It's essentially the same thing we just did, except that the loop structure is different. So instead of saying while and then my long list of conditions and then do and end, it says repeat until volunteer. In the loop, it does the phone call, it flips the coin, it increments the counter, and then it does something else which keeps the counter valid as you're doing this. And then it tests to see if you got a volunteer or not. The thing about the repeat until loop is this code will execute one time, no matter what. So if in your code, if somebody, for instance, volunteered last week that they'd bring pizza this week, and you wanted to be able to test for that, the repeat until loop would not be a great fit, because it's going to call someone before checking to see if anybody's volunteered. This code will run one time no matter what. If that's not what you want programmatically, then you should not use repeat until. Could you make it work? Yes. But if it's a 0 or more scenario, that's not what repeat until is designed for. Repeat until is designed for a 1 or more repetition. All right. The last thing is I've got just a quick activity that I want to describe and maybe get started on. And so this is your activity to finish and submit for the 3 galleons for today instead of a quiz. The activity is to use your favorite loop to draw the number of clovers entered in the text field at random XY locations. You can use the 4-leaf clover image that's in the chapter resources. We've already used it a couple times, and it's pretty straightforward. Let me get you started on it. So I'm going to start with a fresh design. So if I want to do this, I need the 4-leaf clover. So I'm going to add, there we go. There's the clover. I'm going to resize it so that it's not gigantic, and move it off screen. Then I want the text area. Again, it's a widget. It's in the widget palette. It is not a widget to Corona. It's a native component. There's my text field. So my stack is starting to get, a little larger because Code's generating stuff for us. But I have an event handler and some code in it. So I want to be in this snippet, and I want to display the 4-leaf clover somewhere in here. Here's the snippet. So I want to be in here. This is the text submitted portion of the handler. We're only concerned with when the user has typed something and then hit return or done or whatever on the keyboard, whatever the keyboard that slides up says. Then we want to get that number and then use it. Obviously, I added a huge question mark. You can do that, if you want to. Just a bit of text and it has a question mark. I cranked the font up to be fairly gigantic, but here's where I want to be editing. And so first off, we do need the number, right? So I can say n equals, the text field is object2.text, and remember that it probably will need to be a number, and so getting it out this way may screw Lua up. So we'll say to number object2.text. What I've got on line 30 there should get us the number that they enter. We could say n equals n just to test it. That should get us this app. There's no clovers because the clover's off screen. But I should be able to type a number in here. And when I submit it, I should get this at the console, which tells me, hey, you did it. You read the number in. So the next question, which is what I'm going to leave you with, is well, you're right here. If you're following along, you're somewhere around right here in the code, and you need a loop. I'm going to leave it up to you to pick the loop, but you need a loop and produce n clovers. You will need to move the image into this function and place it inside of the loop. That is what will make multiple of these images appear. But I want to leave that for you guys to tackle. So this is what I wanted to get to today, which was to set you up for this last activity, which hopefully is I don't think it's a challenge, but hopefully it'll make you think, and it's fun when it works, because you'll get this splay of clovers all over your screen of the number that you asked for, which is always kind of cool. So that's all I wanted to get to today. We'll pick up with our next topic on Thursday.